Hi everyone, welcome. My name is Somaya Sadat. I'm the Assistant Director at the Carte, Center for Analytics and AI Engineering at the University of Toronto. It's my absolute pleasure, along with my colleague Alex Olson, to welcome you all to this seminar today. Before we start the seminar, just a couple of housekeeping announcements. This seminar is being recorded and the recording will be posted on our YouTube channel. And I'd like to ask everyone to please type in your questions in the Q&A box and we'll try to get to them at the end of the seminar. Without further ado, I'd like to ask Professor Chen, our moderator today, to introduce our speaker.
Hello, thank you everyone for coming to this Carte Industry Seminar Series. Today we are very excited to have Jeff Schmidt talking about oil and water or vinaigrette, the forklift industry and data science. So Jeff is a data scientist for the Advanced Research Department for the Raymond Corporation since 2015. Jeff received his BS in Computer Science in 2006, his MS in System Science in 2012, and is currently a PhD candidate in System Science at Binghamton University. At Raymond, Jeff has worked on real-time data pipelines, productionalized ML models, cloud deployment architecture, job shop scheduling optimization, and other research-related projects. Research interests include biological plausible neural networks, sensory substitution, and unshakable interest in cryptocurrency. So we're very honored to have Jeff. And for those of you who have questions, please feel free to type into the Q&A box. In the end, we will rally these questions to Jeff and we'll have a discussion afterwards. So, okay, Jeff, the floor is yours.
Awesome. Thank you so much. Let me share my screen. Okay. So thank you, Professor Chen. Appreciate it. So the talk is titled Oil and Water Vinaigrette, Data Science in the Forklift Industry. I don't know if you just saw, but my tongue was in my cheek. So my name is Jeffrey Schmidt, and as mentioned, I'm from the Raymond Corporation. So what are we going to talk about? So I'll give you a little bit of background on who I am, a little bit of background on the Raymond Corporation, and discuss kind of what I'm dubbing off-trend data science and some of the perspectives associated with that. And then to kind of further on that view, I'm going to provide a window into this kind of off-trend data science through an example. It's a least cost prediction that is productionized that our dealerships use to appropriately cost their leases. And then we'll pivot a little bit to data science opportunities. So what further opportunities are there in this and similar fields? I mentioned vehicle manufacturing, but this probably is broader than that. And then last, the verdict. So for a little bit of background, as mentioned, BS in computer science and MS in system science. So that work was kind of related to network science and generative network automata. If anyone wants to Google that work, that was work done, and I expanded it from my PI, Hiroki Sayama at Binghamton. And I'm currently a PhD candidate in system science, expanding upon that research. So my professional experience, so finished my BS, and then I went to Universal Instruments as a software engineer, which is an interesting company. There are very few companies of its kind in the United States, but it makes surface mount machines that build circuit boards. And again, if you're interested, you may not be, but the problem that I worked on was a flavor of the traveling salesman problem in that role. And then I left industry and went back to school for full-time for my master's, and I spent 3 years as a research assistant. And then I went back to industry again, and just celebrated 6 years a data scientist at the Research and Development Services Group at Raymond Corporation. So what is the Raymond Corporation? So predominantly, they're a forklift manufacturer, and specifically under that umbrella, we make electronic forklifts, electric forklifts. So there's internal combustion, generally, natural gas, or others, not gas or diesel generally, because these operate indoors mostly. So, so in 2000, we were put under the Toyota Industries Corporation umbrella. So we are a Toyota company, and we have a pretty long history. The company was founded in 1922, and we kind of planted our flag in 1939 by patenting the double-faced wooden pallet. So if you've been to Home Depot, Lowe's, or Costco, for example, and seen a pallet, a wooden pallet, we patented that. And simultaneous with that patent, we cleverly patented the hydraulic hand lift truck for pallets, so that we could standardize the process and start to sell pallet movers. And yeah, below that's a recent product line. So that's just kind of a sample of the forklifts that we sell. Okay, so let's talk a little bit about off-trend data science and some perspectives here. So especially students, I imagine, would be interested to know what the differences are between, kind of the high tech, maybe fintech, and off-trend. So in the high tech industry, and Sumie mentioned that you have a lot of high tech folks come in for talks, so I'm sure you know this, but some of the differences are regarding data science is increased specialization. So if you look at job offerings in the field, you'll see things like ML ops, DevOps engineers, ML engineers, data scientists, of course, ML research engineers, deep learning engineers, et cetera, et cetera. The list goes long. And generally, the high-tech sector has access to bleeding edge tooling and or custom tooling that they've developed. Some examples, for data ingestion would be Apache Kafka. I believe that was developed at LinkedIn. And some others, and I'm sure you're familiar with some tools that have been developed, data science tools that you're probably using now for your classes, developed at Google and Facebook and others. One important distinction is that generally, the data platforms have been designed in those companies with ML and data science in mind. So that's a key differentiator. They're generally newer corporations, post 2000, and they really have a special focus on data. And you can see that as well with the data volume. Generally, their data volumes are really high. And then off-trend. The environment necessitates generalization. So you need to have a broad array of skills, and if you don't, you will acquire it, because it's generally, it comes with the territory. This is good though, because it exposes you. Whereas in high tech, if you're tunneled into a deep learning engineer, you might not touch some of the other areas that other folks are working on. In general, you're reliant on existing tools or nascent data science tools. So this is a challenge at first, and this generally you'll have to participate in rectifying that issue. You will be interfacing with legacy data systems. So a lot of manufacturing and industries have have been operating for quite a while, and that means that they're likely still using some legacy systems that you'll have to interface with. And in general, in contrast to above, you generally have lower data volume. Right, this is a generalization. There may be higher data volumes, but likely it's not being captured or utilized. And one thing is you'll have to navigate skill gaps and lower adoption, because the high-tech sector iterates quite quickly, and with custom tooling and new libraries, they're developing faster. So you'll have to navigate that area. And then what are the skill differences between the two? And this is kind of references the template above. High-tech specialization necessitates depth over breadth. Right, so you'll have to peer into the research in a very narrow way, and gain very deep experience in that subfield. And it would be good to have some open source software experience. If you're working on custom tooling in these sectors, generally the trend, at least in data science, is that software will eventually be open sourced. So code practices, experience developing potentially, and experience with source code control, all of those good coding practices, all those would be required. And then for the depth over breadth, right, a publication record is good to have, to demonstrate your deep experience in that particular subfield. So this one I kind of wavered on a little bit, but communication and networking skill is not a top line focus, I wouldn't say. This obviously, these two can help you move up in the company, certainly, but I wouldn't say it's a top line focus. And you'll see later, it's a little bit more focused and off trend. And then experience, because of the larger data volumes, it's good to have some experience with some clustered kind of data analysis, data science tools. So Spark, for example, MapReduce, those type of things, because likely you're going to have to be processing large data sets. And off trend, so breadth is a significant benefit. So it's good to be a jack of all trades here, some experience in a lot of different things. And yeah, but by the end you will. And then the second one I mentioned in the previous slide, you'll likely need to push the organization to adopt more powerful tooling. I'm nearly positive that this is what you'll experience if you go into off trend. You'll likely have to champion this effort. And kind of with this is the communication and networking. This is important to establish good contacts within the organization, especially within IT, and also the managers of other departments, because you're going to have to convince the organization that a shift in tooling is necessary, and you're going to have to communicate that effectively. And then smaller data sets don't require these kind of cluster tools. So So that's less of an importance. Knowing of them and kind of how they work is good for the future, but in general, it's not a hard requirement. Right, and then the last, you might need to assume a data science advocate role. Because of the potential skill gaps, you might have to, and in general here, it was different in 2015. When I joined, it's starting to change. At that point in time, data science wasn't as big as it is now. So most of the managers within the organization have heard of and understand the importance of data science. But one thing that you might have to do is really communicate what's needed, and kind of like garbage in, garbage out, right? That data is and the integrity of data is important, and the limitations. So it's important to make sure that it's not a panacea, that there are some limitations. And then you may also have to take on more of a teaching role for tool explanation and teaching, potentially Python classes, R classes within the organization, or establish a group of like-minded people and kind of raise everybody's level of skill. So with that, I want to describe to you what data science was like at Raymond in 2015. So just plopping down, getting hired, the tools that were generally available were Excel. That's kind of the main tool that the organization used and analysts used. SQL scripts, stored procedures. So we're a relational database house. Very few NoSQL databases. So SQL was predominant, and then local installs of R and Python. And my data science focus at that time was combining data from multiple sources. So using SQL Alchemy and an ORM library, I could pull data from multiple sources, combine them. Similar, we didn't have a data warehouse, so I kind of had to use a poor man's data warehouse here, and then using that data to generate automated reports in R Markdown, and descriptive analysis of unanalyzed data sets. So identifying where the data exists within the organization, and then started doing some analysis on that data. And where are we now? So we've come a long way, and there have been some steps in between. But right now, we use Domino Data Lab for a data science platform. So this is, I would describe it as kind of a top tier tool that allows a lot of flexibility for data science. And there's been some push internally, and we've adopted Power BI, Microsoft Power BI. So that's kind of for the analysts within the organization, that's been good. And we have cloud now, so we have cloud access, Azure, and a deployment of Elasticsearch and Kibana that I led within the organization. So that our first NoSQL database. And what is my data science focus right now? ML model development and maintenance. So that's kind of a jump, right? We've made that next step. We also have Dash app development within Domino that allows us to do some, visualization and interesting things. And we currently operate a little bit as a data science service. So other departments have requests or asks, and we can service those asks. And there are opportunities for object detection, segmentation, other training techniques. This is we can do this because Domino Data Lab offers, it's hosted in AWS, so we have access to GPUs and such. So we can fully leverage everything that data science, most everything that data science has to offer. Okay. So let's talk a little bit about this lease cost prediction as an example, and we can tie everything together here. So first, a little bit of background about what forklift leasing is. So this is, you're going to be familiar if you've ever leased a car. This is very similar. So the lease contract contains, it's a contract length. And instead of like, the number of miles, it's the forklift usage. In our case, it's called dead man. What that is, that's a pedal in the truck that you have to step on in order to utilize the truck. And that accumulates hours, similar to an odometer. So, and there are, we currently have 4 options of additional coverage if you want to put everything together. So similar to a car, you can pay for the maintenance up front. We extend that a little bit, but yeah, the first one is scheduled maintenance. So we can cover scheduled maintenance, and that's wrapped up into the cost of the lease. The next stage is scheduled maintenance and periodicals. And then it's everything that includes, and then fork to bumper. So this is all service cost for the truck. And then the last one includes some wearables, the wheels and tires, which is a commonly replaced wear part. So, and the important thing here is that the service costs outside of SM, scheduled maintenance, is the target that we're looking to predict. Okay. So what did our historical lease calculator do? This sounds a little silly, but not to knock it. At its time, it was very good. So what we did is we would construct a survey. That survey was then sent to a number of dealerships. Those dealerships would fill out that survey data and then return that. We would compile it, all of that data, and we would create regression models to fit that survey data. And then we would take those models, embed it into a web-based calculator, and then we would repeat this process yearly. So this is kind of out of necessity. We didn't have, when this was developed, we didn't have, data automatically being sent to the organization. So what were the problems here, and what are the opportunities? So the main problem, as you could imagine after I read it, is that department turnover resulted in stale data and models. So the surveys stopped being sent out, and thus the models were not updated. So that worked for a while, but obviously that would deviate over time, especially when new models, for example, new truck models were released, that wasn't incorporated. And a significant number during this time, or since the rollout of that system, a significant number of dealerships were using common data platforms. So in order to run their business, a number of companies started selling products to capture that service data. And some of those floated to the top, and some of our larger dealerships, most profitable dealerships, were using the same system. So that affords us an opportunity. We could potentially do a data-driven approach using that data. And an opportunity here was a recently employed data scientist. aka me. So, so a little bit about dealerships and the specific service data that we were given. So dealers are similar, our forklift dealers are similar to car dealerships, except that the forklifts do not leave the factory or leave the warehouse or distribution center. We have to send, let me, 1 second. Yeah, so we have to send an individual to service that. So we support renting, leasing, and purchasing. We're specifically talking here about leasing, but there are other options. And there's also service contracts that can be purchased or included. And there's also, we also have a manufacturer's warranty that's utilized there. So, and okay, so let's talk a little bit about the service data. So every time a service tech is sent out to the field, a work order is generated. On that work order, we have labor hours and parts used for each of those work orders, a forklift serial number, and the deadman hours, the meter hours are captured, and numerous fields for categorizing the service type, scheduled maintenance, certified, that should be certified fixed price maintenance, and breakdown, other things. So a good point from a data science perspective is this is a quite sizable portion of information within a dealership, and it's used internally for for determining profitability. So this has a direct impact on the financial health of the dealership. So this data is high quality, essentially. So and currently we're in the process of standardizing all the systems. When this was rolled out, we hadn't fully standardized. 1 second. Yeah. Okay. So here's a description of our first iteration of the lease prediction. So the dealerships, we asked the dealerships for 10 years worth of data, and then on a rolling basis, they would send data to us. So those dealerships sent data back to us, and we compiled that data with other data within the organization, enriched the data. We cleaned and processed the data. This is all local. And then we sent the data to a service called Data Robot. And we'd run the service, it produced a model, and then we hosted that model within the service, and that would communicate with our web server, which would be the front end calculator, and that would send REST API requests to the model. And those were two things, predicting labor hours and parts cost. Those be combined. I said breakdown cost here, but it's really service cost. And then, based on the contract data that the user would input, we would calculate what the scheduled maintenance plan would be for that contract, which is essentially a lookup table. And we'd combine that with what came out of our model, and that would be the lease calculation. So, right, so this was probably 2 years after I joined, we adopted Data Robot. And it's an important point that in these kind of off-trend, in general, because you don't have huge numbers of data scientists, you're going to have to leverage tools to help you. And at the time, we had adopted Data Robot, which I'll mention just as a side note, the CTO of DataRobot is Michael Schmidt, no relation, but he had done some interesting work with genetic programming under Hod Lipson at Cornell. That's interesting for those that are curious. His work is really quite cool. So anyway, so we leveraged the DataRobot platform. It just ran a number of different models against each other, and it picks the best one based on the fitness function that you provide. And the best fit here was an XGBoost model. So about a year later, we stopped subscribing to DataRobot. So we had to, I had to, this was a productionized system, so I had to scramble a little bit. And the pieces that were changed is I had to do these models from scratch. So I had to train these models locally and parameter tuned. At this point in time, I did improve the models to include days in service and not just kind of this dead man. And then I Dockerized those models, and those were hosted in Azure. And everything else about the system was the same, just the API location. And then I went a little nuts and allowed for you to change the models in place without bringing the system down. So you could update dynamically without having the system have to go down for maintenance or anything. So yeah, so then we moved and then we adopted Domino Data Lab, and now Domino Data Lab, the work is not done locally. The cleaning and processing is done in the cloud. Model creation is done in the cloud, and it has the ability to host those quite easily and provides API access. Okay, so let me share. Let me share another screen here. Let me stop sharing, and I will share my screen. Here we go. Okay, so here's an example, just a brief example of a Dash app that we created. So this is the data that I described. So this is for a specific forklift. What you're seeing here in the blue is the data here, and you can look at this. It looks like there's almost like a trajectory. This trajectory is actually a single truck. So you can follow this individual serial number along its trajectory, and this is labor hours here. So so the data is in blue, and then the surface plot is the model result. So you can see here, this is just an example of a visualization of the models that we're using, and this is for every model truck and a number of other slices on the data. But yeah, so that's just kind of an interesting visualization that we can do. And let's do this. Okay. All right. Okay. So let's pivot a little bit to data science opportunities. So are there other areas that where data science is happening within the forklift?
Sorry, Jeff.
Yes.
Sorry. I think now you're showing the whole screen, so we can see.
Yes. Okay. Yep. 1 second. Thank you for that. Okay, is that better? Okay. Skip. Okay, so yeah, let's talk about some of the other areas of opportunity. Okay, so opportunities abound. We've got lots of things that we can do, and some of which we've investigated or are in the process of doing. But number one, reliability-centered maintenance. So determining part failure, part wear. This is an interesting problem because actually this was an interview question from Steve Medwin, who's also on the call. But what I'm dubbing the Toyota challenge, and because Toyota is focused so much on reliability and quality, they have a unique perspective and way to look at failure in the field. So you could imagine or one way to approach this would be to say, okay, if this percentage of failures happen for this part, based on how many trucks are out there, let's look into this. But Toyota takes a different view, and it's a static number. So this is, if we have 3 failures in the field, we have a campaign to address the failure. So this presents an interesting challenge for data science and reliability-centered maintenance, is that is kind of a moving target. You can see failures in the field, and once you have enough that you can make a decent prediction about the failures, likely that's already been fixed and rolled out. So this is kind of an ongoing challenge, but we do have kind of this line item service data that I described from the dealership. So this is an interesting challenge, and we actually have some published work with the University of Wisconsin on this, and they created a sophisticated Bayesian model to kind of address this problem. And I think it's still useful to look at here. I think we can relatively accurately predict some wear parts and other parts, but it's definitely a challenge. So there's an area there of research that might be interesting. The next one is high resolution time series data. So this is like an electric car or just a regular car. There's a lot of sensor information and chatter across the communication bus, and what we've been thinking about is can we bring kind of the Formula One idea into forklifts. Those of you that follow, at least from a technical perspective, Formula One, they have sensors all over their race cars, and they accumulate terabytes of data from the runs, and there's a lot of information there. And to the right hand side, this is just an example of some data that we have available to us. So what can we do here? We can do some performance modeling and monitoring. So because of the robustness of the main components that might fail in a forklift, electric motors are generally pretty stout and pretty robust. And if they fail, it's kind of a big deal. So they generally don't fail that often. And the result of that is that we don't see them fail in data. So, but one thing that we can do is we can track the performance. So if there's any shift in performance, we can track that. So that's an interesting area. Potential behavior modeling. So some of this data includes user inputs. So there's an opportunity there to kind of model the behavior of different operators. And that kind of opens up a number of questions that might be able to be answered in an interesting line of thought. And then anomaly detection. And we've done some work on this, and a good number of the anomaly detection methods are static, like static threshold. It would be interesting if we had some sort of like unsupervised learning approach to that could have reliable anomaly detection. So that's another area that that would be pretty interesting. There are also areas in deep learning that that are opportunities. Autonomous forklifts are certainly a thing. I don't know if anybody on this call will be attending the trade show, forklift trade show MODEX, but we will be in a booth with a third party demonstrating some interesting autonomous forklifts. There's also forklift specific safety systems. So one can imagine using object detection or segmentation to help us with the safety profile and in navigation for the forklift. And then the last one here is Industry 4.0. So a number of the manufacturing machines are generating data, and we can leverage that data to improve the manufacturing process. A significant trailblazer in this area is Porsche. I'm not sure if people have seen the videos online of Porsche's factories, especially the Taycan factory, but it is it's fascinating. They're doing some really interesting stuff in that area, and we have a team that's looking at this. Okay, so the verdict. What is the verdict? It's pretty good. Could use a little bit more lemon juice, a little salt, and a pinch of oregano. I think it's certainly better than plain lettuce, though. But I think there are a lot of opportunities in this kind of off-trend data science. There's a lot of opportunities to learn. I've certainly learned an absolute ton since I started working at Raymond, from cloud infrastructure mentioned in the bio, real-time data pipelines, lots of stuff that I've learned that likely I wouldn't have delved that deep into if I was at kind of a very specialized role at a high-tech company. So and so I hope it's been helpful for students, and if there are any professors here that some of the opportunities that I mentioned look interesting, feel free to reach out. My email address is down there. So thank you very much. I really appreciate the offer, Sumie, to attend, and thank you to Steve Medwin for volunteering me.
All right, thank you, Jeff. It's a great talk. It's a great talk. We have a few good questions in the Q&A, and I have a few questions from myself. So
Okay.
Shall we go over them? Okay.
Absolutely.
Yeah. So the first question from the audience is, how different is being a data scientist in industry in comparison with in academia? I mean, I think that's probably a perfect question for you, since because of your sort of dual role in both fields.
Yeah.
So what are some tasks that require most of your time in each of those roles?
Oh, that's an interesting question. I think it comes down to practical deployment and productionization. I think in industry, I've learned an enormous amount about how to productionize the things that I learned in academia. Lots of that stuff I wouldn't have the opportunity, or it's not, building a library, for example. is kind of useful, but scaling it out and making sure that that it works live is another skill altogether. So I would say on the practical that it's really expanded my knowledge, and that's what differentiates it from academia.
I see. So to summarize, in academia, you sort of play with ideas and sort of you don't really need to go to the end and to see it like being deployed in a real environment, right? So that I think that's sort of what industry focus on, but in academia, it's not that necessary in some sense.
Yeah, it's like a horse with blinders. You're very, very focused on a very specific question.
Right. Like TSP, like you were doing, right?
Yeah.
Yeah.
Yep.
Okay. So a follow-up question from me, actually. So I know this kind of data scientist in industry, especially in sort of off-trend industry, is relatively new, but what do you see as a career path? So for example, if a new data scientist come in, what would the future, I don't know, 20 years in the future look like in this path?
Well, I think there's a lot of opportunity here. I think in general, I mean, just looking at when I joined to now, there was a significant advancement in the capability of data science within the organization. And I think that will continue to grow in these kind of off-trend areas. So if I were to guess, I would say that there's going to be a significant demand for folks that are skilled in data science in kind of these off-trend areas, at least from what I've seen and from what I've seen from our sister companies. So I think that'll continue to grow, and you'll start approaching kind of the capability of off-trend, or maybe these custom tooling, for example, that are developed at high tech in the high tech sector will develop, but for the specialized use cases in the off-trend industries.
Okay, thanks. That's great. We have two other related questions. I'm going to ask them together. So Cheryl asked, how does the latest software, such as those offerings by AWS, affect the data science job role?
Yeah, so there's a lot of like plug and play, kind of pick a block up and plop it down onto a screen, and then you connect the dots, and then the data comes in, and then 3 blocks later, then you have a solution. That was kind of like what a data robot offered a little bit. So the flexibility that you have is limited. It's like, can you create a general solution to all problems? And I think that's difficult. And a lot of these tools are attempting to do that. And I think out of necessity, they kind of limit the flexibility of what you can do. It's possible that Microsoft does it, or that AWS solves this problem, but I kind of I like the flexibility of manually being able to create models and kind of let my creativity go without any constraints, right?
I see. Yeah, so that basically answers another question. So the other question is, what is the tendency in your field having more data scientists to develop and run the models more locally, or subscribe to automatic modeling pipelines? So I think you definitely prefer the first one, because you can deploy the model yourself, you can tune the parameters, you can make the model fit into your scenario like sort of more closely, and that actually helps. So that, I think that's your answer, right?
Yeah, and just referencing a data robot here, one of the things that were touted when we were subscribed to data robot is that it would compete in I think it was like the top 10% of Kaggle competitors, but notice they said the top 10%, right? They didn't say the top solution. So I still think there's opportunity there for human creativity. All is not lost. But it is becoming more of a trend, certainly.
Okay,
Yeah.
that's great. So I have a follow-up question. So in the end, you mentioned that there are a lot of more things that can be done in this area, especially compared to the sort of high tech. The off trend is still have a lot to grow, improve. So it seems to me that there are two sort of dimensions that it can grow. One is, like you mentioned, collect more data, right? So like high resolution solutions, like install sensors to get like sort of infinite amount of data. And so, I mean, then you can develop a richer set of models. And the other is to sort of hire data scientists to implement better models, like for the existing set of data set. So which one do you think would be the first order improvement, let's say, in the next, I don't know, few years?
I would say the liberation of additional data. I think there's real opportunities there, and I will say, from if we just look at it from an automation perspective, there are a lot of companies that are creating autonomous systems for cars, but in this industry, inside of a warehouse, you have a much more controlled environment. There's real opportunity there to make much larger gains than a chaotic world outside with weather and other kind of random factors. So that's kind of one area, but also I think from communication data within the truck, I think there are lots of opportunities there to really expand.
Okay, that's great. We have actually a few questions more specifically about survey. So Jay asked, what would the survey ask for exactly? And I have a like sort of related question, which is, it seems to me gathering data from survey is a little inefficient, right? And if there's a lot of non-response, and that's like selection bias, for example, going on. So have you thought about making it more automatic in some way? Like,
yeah, so maybe I didn't hit upon this specifically or enough, but that was the legacy system. So the way the system works now is that those dealerships that are on the common data platform automatically send us their data like a monthly interval, for example, and that data is automatically sent, and then we process that data and we can update the models accordingly. So yeah, so we replaced the survey method. That was the catalyst, for example, for replacing the survey method, was that these models got stale because we had a lot of turnover. So that was the legacy system. Now we have automatic data uploads.
Right. So whenever there's a new request coming into the dealership, this request will be sort of wrapped into data format and they'll send to you automatically. So the dealers don't have to answer anything, right? Specifically. Basically.
Yeah. So yeah, this isn't, and this is not survey related. This isn't questionnaire related. This is purely the data that's collected for internal purposes at the dealership when a service technician goes out to service a forklift. So he fills out all of this information about where did I go, this work order, which parts did I replace, how many hours did I work on this, and that's important for the business, for running the business. All that we do is we just collect that information and then utilize that to determine the costs.
Yeah. Okay, that's great. So we have Divan asked a more sort of specific question about the ML machine learning side. So
sure.
How do you decide which measurements to take to use in the model, and do you do any sort of feature engineering? So I have a related question, which is like, what is size of your data set, and what are typical like features or variables in the data set that you feed into the model?
So the raw data, just kind of as a perspective, the raw data is a little bit over a gigabyte. When we churn that down, we're looking at a couple hundred megabytes per group. So we have one group that's one set of data that's for labor hours, and then the other set is for parts cost. They're about 100 or so, or about 200 megabytes apiece. And then, so there is some feature engineering. I think a lot of it is data cleansing, though. I think a lot of data cleansing, and as per the kind of the fitness function, it's experimentation. So right now, based on what, so this is an XGBoost model. So based on what fitness functions XGBoost support, and I've also tried custom functions, but R squared, gives us the best result. So in our case, it's not super complicated. We're just trying to fit a surface that's essentially the mean surface through the data set.
Right.
And I will say, with regard to opportunities, there are more opportunities here. So the variance in this data can be explained by a number of different things. I added days in service as a component, but there's also location. For for instance, is that we have a like a, what is it? What's the technical term for it? It's like not livestock, but it's like a chicken warehouse, whatever. Anyway, so there's different components to or different environmental factors that affect the truck within those specific environments, and those have an effect on the cost of that truck over time. So, when we get to the point where every dealership is on the same system, then that really opens up opportunities, because we'll have a lot more data, and we can start segmenting and breaking apart that data based on specific dealerships, or even specific company types, or industry types, those type of things. So and this kind of relates to your other question. I think that's where, at least with regards to this model, that's where we could gain some more improvement.
Got it. Okay, so I think we maybe have time for one last question. So there's a student asking that if the undergrad, so his or her undergrad is in statistics, economics, and he or she planned to do more kind of data science in the master program. And the question is that good enough, or like when is the best time to try to sort of lay down the foundation of data to be a data scientist in the future, in your opinion?
So is this kind of a question of whether he should go to industry, or whether he should continue with his master's in data science? Is that kind of the crux?
Right. So I think that the undergrad is in statistics and economics. So I think the underlying assumption that doesn't touch coding too much, more like theoretical side. But in the master's, start to learn coding, start to learn like deployment, for example. Is that enough?
Yeah. So I would say coding is becoming. I think it's very important in general. The flexibility and what it allows you to do is pretty significant. So I think that's kind of a requirement. I would say, based on my history, is try to get your learning, your education out of the way earlier. It's become harder and harder to get that education complete as I get older. So I would say try and get it out if you can. If you have the financial capacity to do it, try to get it out of the way early, or just when you're younger. If you want to work on it while you're working, that's fine. You just be younger so that you have more energy.
Yeah. That's great. Yeah. Jeff, I think that's all. I mean, that's all the questions on Q&A, and that's great talk. I learned a lot from it.
Oh, excellent. Well, thank you, Professor Chen. So yeah, I really appreciate you giving me the opportunity.
Thanks a lot. This was very interesting. I wasn't expecting anything about that, but it was really, really interesting. I just want to read one of the comments in the chat too for you. As one of the Raymond dealers associated where I work, our business intelligence department has grown from 3 to 10 staff members in less than 5 years. Lots of opportunity. Thanks for your leadership and presentation, Jeff. So, thanks from everybody.
And I got to give a shout out to the dealerships. We have some excellent dealerships, and even on their own, without corporate support, they're doing wonderful things, even with regards to data science within their own organization. So, they're doing a great job on their own as well.
Thank you all. Thanks a lot, everybody, and thank you, Professor Chen. Thank you, Jeff. Thank you, Steven. Great. Thanks a lot.
Yep. Thank you.
I'm gonna just end it because we have time. Bye.
Bye-bye.